Okay, in this video, we're going to be just practicing more on how to contextualize word problems with, well, quadratic functions. Let's put it that way. Meaning we're going to put word problems with quadratic functions in different scenarios. And actually, at the same time, part of the whatever the goal of the whole semester is to get you to be able to express um, these answers and understand the whole topic in a multiple variety of ways. So notice if we're talking about quadratic equations, you can do everything using a table, a graph, and factoring, quadratic formula, or technology. So I don't know if we'll get through the whole thing in this video, but in the next video or two, I'm going to try to cover all this and just kind of review everything for you. Let's go ahead and take a look at the first one, where it says using a table, you have a function. And there's no words behind this really, but they're going to ask, or that we are being asked to solve a function when the output is equal to 0. Doesn't matter if they read it f of x equals this or this equals f of x. Question's the same. The y value is 0. And it's important to notice too that the x, as far as the input and the output, you can always make note of that. But this is really x, this is really y, this is your input, and this is your output. Okay? So for an output of 0, they're asking you for, and I just put, they want the in, or you can put input. But really, you have to be given everything but one thing when you're being asked this kind of a question. So using the table, which is this whole thing that's right in front of the screen, when is the output 0? Well, be careful. There's zeros all over the place. There's a 0 at the top. Well, there's a 0 here, but that's the input. I don't care about that one. So let's not talk about that one. Let's talk about where the output is 0. So in that case, it's right here using the table, excuse me, and right there using the table. So your answer in this case is simply 0.25. Notice approximately, and x is approximately 1.5. So you have two answers, and it is that easy and that fast. You don't have to use the table or any other method. Excuse me, not the table, but the equation, if you don't need to. Okay? And I wrote those answers in the wrong place, of course. Approximately 1.5. Let me clean this up. But the next question is going to be solve the same function when the output's 9. Now, if you were trying to do this again, the whole goal here is trying to do it, um, practicing these different varieties of methods. But if I wanted to figure out when the output is 9, you got to come in here and notice what's happening as my input goes up from 0.5. In other words, as my input goes this way, watch my values. I go from a negative output to 0 to 6 to 10 to 12 to 12 to 10. In other words, I go up and I come down the top, or the probably the maximum somewhere in here. If it's not 12, it can't be 12. It's got to be somewhere in here, in this region here. So I'm going to hit 9, in other words, somewhere before I hit 10 and sometime after 10. See what I was trying to accomplish there? So let's clean this all up again. And again, the question is, when's it going to be 9? Somewhere in here and somewhere in here. See how I'm looking at my values? And I know that because, again, using my table, there's a negative right here. And that forces my graph to be concave down this way. So what I'm saying is I have to go up past 9 and come back down and hit 9 on the way back down. And if I'm just to use my table, I am really, remember this sign here means it's an approximation, so it's my best guess. So somewhere between 6 and 10, again, let's erase this stuff. Somewhere between 6 and 10, right in here, you can approximate an x value. Now notice it goes from 0 to 0.25, so maybe 0.2. I don't know, that's a little bit smaller than 0.25. And same thing here, my output of 9 should be in here somewhere. So if I'm looking for an approximate value, notice my x values are increasing here from 0.75 to 1, so maybe I don't know, 0.82. And really using the table, if that's all I'm allowed to use, it's really your best guess. That's why it's called an approximation. Okay, let's continue on. New function here. Now, using the graph shown to the right, solve this scenario where you have one function here. Now, this is going to be in blue. And they already have it drawn here. When does that thing equal -2? And let's go ahead and use green to draw that line in. Now, bear with my crummy drawing here. In fact, I probably can do it an easier way, but hopefully that's good enough, because again, it's an approximation because it's our best guess. We're not using any exact method. Now, if I'm approximating -2, it's going to hit here and here. So what are those corresponding x values? Well, if I look at this one, that looks like, from 0 to -0.5, so maybe that's going to be right in the middle, -0.25. So maybe that's one answer. So I'm guessing this x value right here. And then whatever this value is right after 1.5 also seems to be the time when my output will be -2. And in this case, maybe 1.63. I don't know. I'm making that 0.63 up just because I know it's after the 1.5 that's there. Right? Again, using a table and a graph aren't exact methods. They're just a good way to get started and to approximate values based on very little if you don't have very precise methods. Now, we've also learned throughout the semester how to factor. So remember these steps. You're going to use your algebra to make the equation equal to 0. You're going to factor the thing, and then you're going to set each one to 0 and solve for x. Again, I'll review. And maybe at the end of this video, we'll conclude and start the next page. But if you're going to do this, let's choose blue. To do this, we need to -8 on both sides. Remember, you got to set the thing equal to 0 to begin with. At which point you could then factor. Now, I've done this quite a bit, and maybe I'm messing up, but I think those two factors will work. You can pause the video and FOIL it out to always check to see if you can get back to the original function. But once that's there, you can say either x minus 7 equals 0, or you set the two factors because one of them, for you to have a product that multiplies to 0, one of them has to equal 0. So here's my solutions. Okay, so those are answers for those, and you can always check your answers to make sure they're correct. Remember, sometimes they'll work, sometimes they won't, depending on the type of problem you're receiving. And for part B, stop the video, set everything equal to 0, and see if you can do that one on your own. Okay, and then we'll end the video for this portion. Okay, if you're back, I'm going to do two steps at once this time. I'm going to subtract -x minus 12 from both sides, which is going to give me x squared minus x minus 12 on the left side. All that thing, the whole thing, equal to 0. So once you're there, again, can you factor? And in this case, I think it might be x minus 4x plus 3. So x minus 4 has to equal 0. And again, we're just reviewing, so hopefully this all is familiar. Cool? Okay, so those are your two answers, and next video we'll keep going. Let's see where we're going using the quadratic formula. So before we even get there, go ahead and set that thing equal to 0 and try to do the formula for yourself. Okay? Talk to you soon.